beginning an activity that will last for a few days, and to get your homework started, in case you need a little more help, I'm going to review the goal of the activity and the goal of the learning from all the skills we worked on last week. So we started in class on the computer with the Ferris wheel problem, but for a warm-up we also did a problem called the bag and snacks. Okay, so I'm going to talk a little bit about both of those by first focusing on this focus question for the week, really. And the focus question is, how can we decide when finding common factors or common multiples are useful? So just a refresher of the warm-up, the common factors we used in the bake sale problem, because we had to figure out how to divide up different types of cookies evenly into bags. And we talked a little bit about a sense of justice, that everybody's party bag, for example, should have the same amount of chocolate chip cookies as each other's party bag, and should have the same amount of vanilla wafers. So an example being that we looked at all the different factor pairs to divide up 48 chocolate chip cookies and 64 vanilla wafers, but in the end, when we looked at all the factor pairs on the left, we figured out that the common factors are these numbers on the right. And so we could have two party bags. Each party bag would have 24 chocolate chip cookies and 32 vanilla wafer cookies. So it's not that the chocolate chip cookies and vanilla wafer cookies are an equal amount, but that every bag has the same amount of chocolate chip cookies. So for example, if you had a party with 16 kids, each kid in the party would have 3 chocolate chip cookies, and each kid in the party would have 4 vanilla wafer cookies. So they would all have the exact same party bag, which would make them feel really good because they would feel like it's fair. So when we're dividing items up, we're really looking at factors. And that was our warm-up example. The Ferris wheel problem, right here, actually uses multiples. So question 2 asked us if the Ferris wheel problem was asking us to find the greatest common factor or the least common multiple. And so you should have decided the least common multiple. And you could have your own explanation. So we're going to look at that Ferris wheel video again. And here's the problem. When will Jeremy and Deborah be at the bottom at the same time again?
I'm going to ride this Ferris wheel.
I'm going to try this one.
I've done all the way around.
Wait, I haven't. Now I've made it back to the start.
I'm already back at the top. When will we both be at the bottom at the same time?
So in this problem, the question is, when will they be at the bottom at the same time? And in order to do that, we would have to think more about multiples than factors. So let's go back here and look a little bit deeper into this question sheet. So for right now, we're gonna skip over 3 because we haven't completed too many problems in context until today. But we're really gonna look at question 4 so you can get a good start on your homework and then come back and finish the Ferris wheel problem tomorrow. The large Ferris wheel, here's a situation, the large Ferris wheel makes 1 revolution in 60 seconds. The small Ferris wheel, so we'll do that in red, makes 1 revolution in 20 seconds. How many seconds will pass before Jeremy and Deborah are both at the bottom again? So if we look at the large Ferris wheel, every 60 seconds, the Ferris wheel goes around. So Jeremy will be at the bottom after 60 seconds. And then again, after 2 revolutions, it'll have been 120 seconds. And then after 3 revolutions, it'll be 180 seconds. Whoops, because we just keep adding 60 seconds. And after 4 revolutions, it'd be 240 seconds, and the pattern will continue. But the small Ferris wheel that Deborah's on goes around much faster because it's smaller. So she will make 1 revolution in 20 seconds, and then she'll go around twice in 40 seconds, and she'll go around 3 times in 60 seconds, and then after 4 times, 80 seconds will have passed. And after 5 times, 100 seconds will pass. And the pattern continues. So after 60 seconds, when Jeremy has only gone around 1 revolution, 1 time around, Deborah has gone around 3 revolutions, but they are both at the bottom. So after 60 seconds, they will both be at the bottom for the first time. The large Ferris wheel, looking at this next part, makes 1 revolution in 50 seconds. So now they're saying, what if it's a different situation, maybe different size Ferris wheel? If the large Ferris wheel takes 50 seconds to go around, so a new situation, the large Ferris wheel will hit the bottom every 50 seconds. So 50 seconds, 100 seconds, 150 seconds, 200 seconds, 250 seconds, and the list will go on until the Ferris wheel stops. The small Ferris wheel takes 30 seconds to go around. So it hits the bottom at 30 seconds, 60 seconds, 90 seconds, 100 seconds, 120 seconds, 150 seconds, 180 seconds, 210 seconds, goes around and around and around. So looking at those lists of multiples, the first common multiple, the first time they're at the bottom together, is after 150 seconds. How many seconds will pass before Jeremy and Deborah are both at the bottom again? After 150 seconds. So if we look at question 6, it's a similar problem. And you can come back if you haven't finished that tomorrow and begin class with that. Between this Ferris wheel problem and the bagging snacks problem, you should have a good idea of how to start your homework.